Good afternoon to all of you. What I'm going to talk about today is future networks and the future of the networks. It's a very interesting topic. The reason being that today the way the world is changing so fast, that is catalyzing a change in the way telecom networks of today will evolve to the networks of the future. The topic of my presentation here says make technology invisible for a programmable world, and I will go a little bit more into detail about what I mean by this. But what Nokia is saying as a vision for the future networks is that we want the technology to run in the background invisibly in order to make life simpler for the people. My name is Amit Marwah, and I'm the CTO for Nokia Networks in India. So I start with a little bit of a story, and you probably see a river here. This river is called Nokia Vitra. It is in a small town of Finland, and this is the place where Nokia as a company started. Started from being a manufacturer of paper pulp. So which means that that was how Nokia started. In April of 2015, Nokia completed as a company 150 years of existence, which means that if you Google, you probably find very little companies or very, very few companies who have been able to survive that long. And why I'm showing you this picture is that this 150 years of history of Nokia has been a very interesting journey from wood pulp to paper products, to tires, to rubber products, electronics, mobile phones, which I'm sure was where Nokia was known for. So it's gone through a journey, and in between, as you are aware, that we got out of the mobile networks. And why I'm telling you the story is that Nokia as a company reinvented itself again and again, number of times, in order to look at the future and adapt itself for the future. And that's what we keep doing, and that's the learning from the history of Nokia that I wanted to share as a small story. In the second quarter of 2015, another very bold decision was taken by Nokia as a company, and this decision was to acquire another big giant, Alcatel-Lucent. And together, this acquisition has now been formalized. In fact, the beginning of this year, we have started or completed this acquisition in the phase 1 of taking over as a combined entity. And the reason for this acquisition, if you may, is multiple. And we also started looking at the future of the networks. We started looking at what was happening around us, and we thought that this was a right combination from the perspective of innovation, from the perspective of combined portfolio, very complementing, from the perspective of customer reach, from the perspective of innovation and operational excellence and scale. So there were a number of motivations why we decided to take this big plunge and enter into a new historic phase for Nokia as a company, which we are now kind of very excited about. Now, here is a very simple chart of showing the evolution of networks. We are all aware that networks started from fixed line. We all know that at some point of time we used to have these fixed line phones in our house, and that was primarily the only way of communicating. It moved fast. Mobiles came into the network. And it revolutionized the way of connecting people. And today, as you know, we have 1 billion phones connections or subscribers who are in India itself who are connected, and more than 7 billion connected people in the world through this technology of mobile communication. And then mobile communication got enhanced by internet and the use of internet. And as you are aware, the use or the way internet is being accessed today in the world, or any kind of broadband access is there in any part of the world, is mainly through the mobile technology. So what I'm trying to say is here is that mobile revolutionized the way people connected to each other. So this has already happened, and in the future we are now at the cusp of another big revolution to happen. All of you have heard about, in some ways or the other, of this big thing called the Internet of Things happening. So what we are saying is, from the level that we are today of about 6-7 billion connected devices, it's not far in the next 10 years or so that we envisage that there will be 50 billion connected devices in the world. And these 50 billion connected devices will not be the conventional phones or the tablets or the way that we are used to connecting laptops, etc. But these are going to be sensors. And if you translate that into the population of the world, so what we predict is that, in fact, not only us, everybody predicts that by 2025 or so, there would be at least 10 different types of sensors touching an individual's life, which will not only be phones, which would be sensors in fridges, and which would be sensors in cars, and which would be sensors in water management and many, many other applications. So it's a very exciting time in terms of moving ahead from the domain that we are today into what is coming in the future. And then ultimately what we see or foresee is getting to something which is called a programmable world. Now, we have seen technology evolve from fixed to mobile, GSM, 2G, 3G, etc., going to now the Internet of Things. But what will happen after the Internet of Things, or how will that help change lives? So what we believe is that the Internet of Things, and post the Internet of Things, there will be the programmable world where the technology will not be enforced on individuals, but it will be intelligent enough and added to the data to allow people to interpret and to use it and capture it the way they want to use it. So it will not be enforced, it will be the choice of an individual how he wants to use the technology, and it will not be. That's why we are saying it will play a role invisibly in the background. This is pretty much the vision that we have set ourselves for, if you look at the coming 10 years of how the world is going to evolve. And what we say is, we are remaining a world where technology blends into our lives. Technology that works for us discreetly, yet magically in the background, enriching our lives. That's the kind of vision we have. But there is a downside of that, and that is that for some, this new technology where everything and everybody will be connected can be challenging. It could be intruding. It could be hard to understand. It could be taking control out of your lives. It could be complex, and it could be largely overwhelming. And we are aware and conscious of this fact that it will be difficult for some people to accept this technology. And that is why we focus along with our partners to make this technology help people thrive better in their lives. To effortlessly, simple, intuitively design and enable new extraordinary experiences in people's life in each day. And what we call this is the possibility of technology, or the human possibility. This is the vision or the way that we look ourselves in terms of growing with the world changing, and we say the human possibilities. And I'll give you a few examples of what we mean by human possibilities, and I'll give you, there could be numerous examples, but I'll just give you how technology can change lives. And one simple example that comes to the mind is that a city like Beijing consumes approximately 980 billion liters of water in a year. It is a well-known fact that about 20% of the water which flows from the source into the reservoirs and then gets to the people is wasted through various channels of leakage. Which means that even if you look at a city like Beijing, from 980 billion liters of water is consumed, 20% assuming wasted. This 20%, which translates to, let's say, 180 or 190 billion liters of water, if technology can help save part of this leakage, then this water is enough to source water to a country like Finland for 2 years. That is what is meant by enabling lives or human possibilities. I'll give you another very simple example. In the world today, there are about 1.3 million people who die of road accidents in a year, which translates to roughly about, I think it's 32 or 3,300 people every day. If you look at India alone, out of this 3,300 people, about 400 people die in India out of road accidents. Could there be sensors in cars which can prevent or partly reduce these accidents and prevent some lives? That is enabling human possibilities. Medical systems which are very outdated, which are very cumbersome, by adding sensors into how medical facilities are accessed by people, can lives be saved? This is all about human possibilities, and this is our mission going forward when we look at future networks. So this is the background of how we look at future networks. This is another very interesting picture. Again, very similar to the picture I showed you, but we are saying that we are moving from a phase of connecting to engaging and finally to transforming. And what we mean by that is that you had the connectivity. So you had GSM or 2G technology which you were using for voice, or we all have been doing that. We moved to a higher technology, 3G, and added a little bit of internet into our mobility function in the phones. So we were able to use the internet. We started accessing the net basically. And from 3G now we are moving to 4G or LTE. Going forward, LTE advanced, more technology evolution will happen. Another technology evolution from 4G to 5G will also happen. But what is happening in the whole access of connectivity and how people use, from basic connectivity of just enabling voice, we are moving to engaging people through various channels of the internet. You know, whether it's Skype, whether it's YouTube, whether it's Salesforce, whether it's Dropbox, the WhatsApp. So we are getting more engaged in terms of connectivity with each other using technology. And then finally, to get to the programmable world, you need to transform this into the next generation. And this is moving very fast. And I'll give you a couple of examples of this. You know, to get the first billion subscribers on a GSM network, it took about 10 years. To get the first billion subscribers on a 4G network, it took 7 years. So that's how the technology, so the whole time frame of how technology is evolving in the future is also shifting, and the world is changing very fast, and that's what I wanted to bring it up here. On top of that, the use of all these applications which are there on the internet, you know, WhatsApp we all know, but there are much more new things which are coming with machine-to-machine and IoT kind of communication getting enabled. And finally, the devices getting more mature, which means that the same device that we were used to using in the past is becoming so much more intelligent, so much more user-friendly, so much more, you know, with better camera and display facilities, that the same device will be able to enrich our experience in using the connectivity and the internet and the functions that we are associated with. So this is how the world is evolving from one generation to the other generation and getting transformed. Now, this is another interesting picture which says that by 2020, and I'll give you a very simple analogy which says, you know, up till now what we have seen is in the, you know, for the last 2 or 3 years, the consumption of data on networks across the globe is approximately doubling every year. Let me repeat. So the consumption of data on networks, so which means that in 1 year, if you were having 100 terabytes of data getting consumed in a particular network, then what we are seeing is in the next year, you are on the same network with the same number of people, you are getting 200 terabytes of data getting consumed. So which means the acceptance and use of data is happening extremely fast and also growing. So here is an example where we are saying that let's not even say that 100% data growth is happening. Let's just say a pessimistic view of if data grows at the rate of 75%, which is the line on the top, or 50% or 25%, which are these 3 lines, then by 2020, starting from by 2020, with this kind of growth happening, we would probably need the mobile networks in the world to support 1,000 times more data capacity. And that's where the picture meets 2020. You can see that you will need approximately 1,000 times more data capacities on the networks to be able to deal with the kind of explosion of data usage that is happening. If we go very pessimistic and say, no, this will go only by 25 years, 25%, even then you need about 100 times more capacity on the network. So yes, it could vary from 100 to 1,000 or even explode even more, but that's the kind of the capacities that we need on the data, and networks of tomorrow need to be prepared to be able to deliver that. And of course, there are the drivers, 4G technology or LTE, smartphones getting matured, video becoming very important. Today, in fact, the statistics today itself show that 50% of the data consumption on networks is coming out of video, and this is even, this is just growing very, very fast. This picture that I show now is an India picture. So, we see all these reports, we also do these reports, everybody else does, which says that data is doubling on the networks every year. So we said at Nokia that why should, at Nokia, incidentally, we manage almost like 30 to 40% of the network. So we have a good visibility of what is happening in the network. We supply equipment to most or all the mobile operators in the country. So we are present and we have our reach into the entire networks. We have close to about 4 to 500,000 base stations installed across the country. So we said that since we have so much visibility of what's happening in the networks, let's try to do a deep dive into looking at the data growth in India. And it was not a surprise to us, but we started releasing this report, which is called the Megabit Report. It's available on the internet. If you search, you will be able to find it. But we said that let's try to analyze what's happening in India. And we were not surprised to prove this point that data growth in India is also following the same trends as in global. So from 2012 to 2013, there was an 85% growth in data. From 2013 to 2014, there was a 74% overall data growth. If you look at only 3G, it is even surpassing 100% data growth. So all the facts that we had on table, or we were we were guessing, we were able to prove it in some sense. And this was an interesting report that now we do release on a yearly basis in order to show an India flavor of how the data growth has been happening in this thing. There are many other variants in the report that we take out. We even take out a flavor of how device ecosystem is maturing, how 3G penetration is increasing, what is the comparison of 3G versus 2G. So if you search on the internet, you'll be able to find some of these reports which would be interesting for you to go through. So what is enabling this huge growth? Like I said, 8 billion people connected today. We are saying 50 billion in the next 10 years or so connected devices, and it could go up to even 1 trillion devices in the future. And what is the social change which is incidentally happening in the world is everybody wants data everywhere. So data is available everywhere because data is available on the mobiles. So, and mobiles are mobile in the true sense. So you are able to access data from anywhere. Mega urbanization, there are these huge programs that in India also we keep hearing about digital India, smart cities, etc. So urbanization as well as modernization or digitalization of the urban population is another very, very important social trend which is enabling this growth of data. Everybody wants data instantaneously. You have applications running like Uber, like Ola, like many other, where you are using location. And when you are using location, you want to know instantly what is happening where and then be able to use it. And you want it now, and you want it in a balanced way, which means that you want it to be under the framework of the regulatory requirement, under the framework of a security, encompassed around security so that your data is protected. So these are the trends from a social point of view. And if you look at these trends and then map it into a network operator, then you see how a network operator sees the challenges. So these are basically the 6 big challenges that we see in mobile networks or for mobile operators across the globe, where we are saying, as we said, data is exploding, you need 1,000 times more data. How do you build networks to deal with this huge traffic growth? You want data to be instantaneous. How do you give low latency on the network so that you have instant data available to the people, because that's the demand. The networks are becoming so complex because you had only earlier 2G technology, then you had 3G, then you have 4G. You also have Wi-Fi and you have other access technologies. So, and everybody wants to use all technologies to be able to give as much connectivity as possible. So the networks are becoming extremely more complex. You cannot afford to keep growing networks, so you need to be aware and conscious about the energy, because you cannot exponentially start or consume energy on the networks, because networks incidentally is a very large consumer of energy, and we need to be conscious that you cannot just go all out and keep increasing your energy requirement, which also adds cost into the OPEX. And you need to have flexibility in the network, because today you might have a requirement to give huge data capacity in a certain area, and that requirement may change in the evening, for instance, because maybe the traffic moves from one place to the other and suddenly your requirement. So you need to have the networks to be very flexible. And then the consumers are becoming very aware. So you need to create model and use the information that are there in the network to be able to give to the consumer what he wants and create a value for him, which means that big data and analytics is going to be a very critical thing for the future networks. So these are all the challenges, and when we started studying these challenges, we said that looking at these challenges, as we said, they all translate to approximately 1,000 times more data requirement on the network. And if what we try to do also is that in order to deal with this 1,000 times more data requirement on the network, you will probably need 10 times more efficiency on the networks, which means lower latency and better networks. You will need 10 times more spectrum on the network. You will need 10 times more base stations on the network. Obviously, 10 times more spectrum and 10 times more base stations is not possible to build. So you have to evolve the technology of the future in order to look at these challenges and create solutions which can mitigate these challenges to a large extent. And that is our endeavor. And in that endeavor, we have something in Nokia which we call the Vision 2020. Vision 2020 is that from the challenges of the network operators, we need to build the networks, the products, the solutions in order to be able to support more capacity. And more capacity by way of increasing the capacity on single nodes or adding capacity by way of newer technologies. For instance, when we say you need 1,000 times or 10 times more spectrum, 10 times more spectrum is practically not available in the world. So what do? Then you start looking at alternate ways of using the spectrum more efficiently, so that in the same amount of spectrum you can pack more subscribers as well as data as well as capacity, so that it becomes more efficiently usable. So there are things like carrier aggregation. There are things like the LTU, which is basically means that the spectrum belongs to some other person who is not using the spectrum for the entire duration, and he leases the spectrum to somebody else to use it. So it's again using the spectrum. It's very typical, for instance, in India, Air Force, Defense, aeronautical are sitting on a lot of spectrum which they use it sporadically, or there are these emergency services which use spectrum and they have been reserved spectrum for them, and it's not only in India, it's across the globe. Their spectrum is reserved for them, but their use of that spectrum is only if there is a disaster which happens, which will probably be once in a couple of years, and hopefully not. So can that spectrum be leased out and used by someone else? And as soon as it is required by somebody for the emergency service, it is it remains their priority. So if they use it, they always get the priority. At the same time, it is all. So these kind of things are being thought evolved. Reducing latency, as I already touched upon, making the networks to be self-aware. When we say the networks are going to grow to a heterogeneous network model, where we are saying that you will have these multiple radio technologies, 2G, 3G, Wi-Fi, 4G, 5G, whatever, and you also have a number of more base stations. Now, the number of more base stations, like I said, you need 10 times more base stations. These 10 times more base stations are practically not physically possible. So there will be things like small cell which will get integrated into the network, which will be smaller base stations which can probably fire into the network into a floor or a building or a house, and they will become more relevant. But as this becomes exponential, you cannot manage such a large network by the conventional ways of managing. So you have to have intelligence in the network, automation in the network, so the network can self-heal and self-aware and self-improve itself and get rid of some of these problems on its own. We talked about flattening total energy. So our goal when we create our solutions in Nokia is that you increase the capacity. Let's say we have to go from X to 10X or 100X or 1000X. We will endeavor to increase those capacities without increasing the energy consumption of the network. So you develop more efficient energy solutions. Moving to telco clouds, like I said, and personalization, also I talked about briefly. So these are the 6 pillars of what we call as the Vision 2020 for future networks from Nokia perspective. And delivering, the vision overall is that we should be able to deliver gigabytes of personalized data per user per day in a profitable and secure manner. So this is the overall vision that we take ourselves for the future networks. While we talked about latency, I will just show you this picture of why latency is so important. So the conventional way of using networks, for instance, okay, so before we go into this picture, I'll say that if you have 0.1 latency, so latency is basically, so for people who don't understand, is the response time of when you access something and when you get it back. For instance, you access an internet site and how long it takes to download the page. Or for instance, in voice latency, if you're talking to another person, then what is there a lag in the conversation or not? So latency is becoming extremely important in the future. It is important right now, but right now still you can live, let's say, for channel zapping or video calling or voice calling, with latency levels of 100 millisecond to 500 millisecond. But as and when this new revolution of newer technology, devices, machine-to-machine communication, critical communication coming to networks, the requirement of this latency is going to go down and down and down. And we need networks in the future which will be less than 10 millisecond or even 0 millisecond latency kind of thing. So those are the networks which need to be evolved for the future. When we talk about the networks being self-aware, I'll give you another example why the networks need to be. I already touched on this a little bit, but we are saying that from 2014 to 2020, you will have a 5 times more increase in the endpoints that are served by the networks. You will have 5 times more increase in the network elements, but at the same time, you cannot build your manpower in your organizations, or operators cannot build the manpower in the organization to be able to deal with this exponential. So they just cannot go on hiring and expanding their manpower resources. So the average team of, let's say, 200 people, which today handles about 400 incidents, may end up handling close to 10,000 incidents per hour as a team. And if that happens, obviously physically it's not possible. So you need to build and start making the networks self-aware, self-diagnostic. It should be, the networks of the future, when we talk about small cells, should be to some extent, to give you a very simple example, is you buy a Wi-Fi router, you plug it in and it works, right? You are able to self-configure, you are able to self-heal, and it also does some diagnostic on itself. So you need to make networks predictable, you need to make networks automated, and that will help reduce cost, improve quality, and manage the complexity of the networks. Similarly, when we talk about energy, again a very interesting picture, and a very simple example of showing that from today, if there is a particular requirement in a it's a network where 140 terawatts of energy is getting consumed, then this is being transmitted, let's say, from the power plant. 10% of this gets wasted in various transmission channels. So about 80% of this, or 20% probably gets wasted, because there is other elements, cooling, heating, etc., which also consume this electricity. So 80% of this network energy reaches to the telecom site itself. Out of this 80% that reaches to the telecom site, another 30%, for instance, it gets into many of these other ancillaries, like I talked about, cooling, heating, etc. And you actually, at the network element level, you need only 90 terawatts of electricity. And out of this 90, another 20% is actually not required, because it's within the system. You need some fan cooling, you need some other things to be able to run. So you actually, what energy you are giving from 140 is about 70 watts, which is required, 70 terawatts, which is required for the actual chips, which are the hardware or the electronics in that network. And the electronics is built because telecom is a lifeline. So we have to build the electronics in such a way that it has to be 100% redundant. It has to have many levels of redundancy. So actually, for transmitting bits, out of the 70 watts, there was only 20 which will actually be used for transmitting. So this is the analogy. It's like a funny picture in that sense, that from what you are producing or transmitting from a power plant to what you really require. So can you reduce energy at all these various levels in order to make the networks more efficient? Can you only transmit or give energy for what is required to be transmitted? Of course, it's a very simple thing to say. It's a very complex thing to do. But many things are being done in terms of developing better chipsets which are more energy efficient, finding ways of giving these redundancies in a different way, so that you don't require so many redundancies. Fan cooling has almost become non-existent now. So the hardware that is supplied is completely on its own, self-cooling itself without any fans. So many things are happening, but this is what the requirement of future networks is going to be. And finally, I talked about cloud, and cloud is extremely relevant for the future. Again, like I said earlier, one of the things with cloud is that you have unpredictable amount of data growth. Suddenly you see that in one place you need data and in the evening you need somewhere else, or you need to geographically shift data or shift capacities from one place to the other. So cloudification of the network is another very, very big thing important for the future networks, which will help reduce or create this flexibility, agility in the networks in order to be able to deliver capacities as and when instantaneously available. So you will have networks which will have a cloud of assuming data centers which are supplying the network capacities for various things to various let's say locations. And in one location, if you need more, and the other location you need less, because it's a cloud, you can easily flexibly allocate those resources to one place versus the other place. This drastically also reduces the total cost of ownership, and the reason is very simple, because if you have 100 nodes in 100 locations, then in all those 100 nodes you have to build redundancies, you have to build power, you have to build the space, etc. But if you are cloudification it into a single or 4 locations from 100, then you can build that efficiency and reduce the cost of ownership for delivering these gigabits. And of course, all this also results in much better experience and a faster innovation cycle, for meaning that because it is now at 1 or 4 locations, like I gave the example, instead of 100 locations. So let's say if you have to enable new features or you have to upgrade the network, imagine the time it saves, because you have to do it at 100 locations versus now you have to do it at 4 locations. So the agility of the network becoming modernized and getting new things into the network is also much quicker. So that's the motivation of moving towards a cloud technology. And the last thing is the personalized network experience, where we do a study which is called customer retention study. And in that customer retention study, we discovered that about 30 to 40% of the respondents said that network experience or quality of the network is one of the key criteria why they would like to churn from one operator to the other operator. So that's how important quality. So why I'm giving you this example is that the customers are becoming much more aware. Customers are becoming much more aware and much more demanding in terms of what they want. So in order to be able to monetize and not only to retain, but also to be able to monetize some of the revenues which are going to, let's say, the over-the-top kind of players, the network operators and the networks need to start building this intelligence into an automation in the network, whereby we are able to give differential services, differential quality, and which individual customers require. So young population needs a different kind of experience. You understand where that young population is and give them the customer experience that they want. Some people are more conscious about let's say getting high quality of speed. So they are very conscious about getting extremely high speed. So you give those kind of subscribers are different. So customer experience, what people demand, will be a key enabler not only to retain subscribers but also be able to monetize revenues for the operators in order to give better experience to those subscribers. So the subscribers will get better experience and they'll be willing to pay more. That's the whole content. I will now briefly touch upon in the next 5 minutes or so, and then I'm almost done, on the key trends that we see. And there are many trends, but I've just listed about 5 of them. Key trends on what we see as the networks of the future. And in one of the trends that we see is something which is called single RAN or multi-radio. So earlier, to give you an example, you built a network, so you started building a 2G network and you start putting base stations and whatever network equipment that you require in those sites where you need to transmit to be able to give the mobile experience or the mobility to the connect to the customers. Then comes 3G, so you built another base station on top of it. Then comes 4G, you built another base station on top of it. But that was something which was happening maybe 10 years back. What we have transformed now is that we have created products as a part of the evolution of networks which are called single RAN. Now a single RAN product in a very simple way means that the same hardware can deliver 2G, 3G, 4G, Wi-Fi, whatever is required to be done. So the hardware becomes agnostic of the software. So you can flexibly configure the hardware to, today you need 50% capacity of 2G and you need 30% of 3G and 20% of 4G. But tomorrow 2G traffic is reducing, so you need to reduce 2G consumption or capacities on that network element or that base station and increase 3G and increase 4G. So you can do it flexibly without doing a forklift change of the base station site itself. So this is a very important trend which is emerging and has started happening in the last 5 years or so, where the hardware and software is getting decoupled and the hardware is becoming technology agnostic in terms of whether it's 2G, 3G or 4G. The other important trend is that from LTE today, as I said, the spectrum, like I said, for 1,000 times more capacity, you need 10 times more spectrum. The spectrum is not enough available in the world. There are not enough airwaves or spectrum available in the world. So one of the things which started getting innovated a couple of years back is something called LTE Advanced, and one of the key features of this LTE Advanced is what is called carrier aggregation, where you say that if you have spectrum in different bands. For instance, in India, you have a 1800 band and you have a 2300 band. Now, can I, and the way it used to work up till now or a few years back was that 1800 band is used for, let's say, giving LTE or some whatever technology we are offering, 2G or LTE, and restricted, so the subscribers in that spectrum would be restricted to use the spectrum in that 1800 band only. And the subscribers you will be restricted to use the spectrum in that 2300 band who are using that technology there. So evolution of technology has happened in such a way that now we are able to virtually club these spectrums into together. So you have 5 megahertz here, you have 5 megahertz there. Can you virtually club them together and make it into a contiguous, let's say, 10 megahertz? Now what happens by making 5 plus 5, 10 is that you get these spectral efficiencies, and I'm maybe getting a little more technical, but the fact is that in spectrum, larger chunks of spectrum, the utility of that spectrum exponentially increases. So if you have 5 megahertz, you can pack, let's say, 100 things in it. But as soon as you get 10 megahertz, it's not that you can pack or give 200, you can probably give 400 or 500. That, because the efficiency starts kicking into that. So that's how it works. And carrier aggregation has become a very important thing, which is enabling packing more into the spectrum as well as making higher capacities and speeds available. Like you can see here, trials have been done on Nokia Networks in 2014, 15, 16 up to 1 Gbps, and I think we have even gone up to 3.6 or 3.8 Gbps speeds in recent some Barcelona trials. So they're not commercial, but they are trials where those kind of speeds are also getting achieved now. The other very important trend that globally we are seeing is this movement to voice over LTE. And voice over LTE is an alternate voice technology. So conventional voice is called circuit switch voice. Voice over LTE is more like a packet voice. So it uses the same data channels which are being used for transmitting, let's say, accessing the internet, but it's voice which is getting transmitted. And the beauty about this is, so you probably use, let's say, voice over Wi-Fi. For instance, you do a Skype call or you do maybe a WhatsApp call. These are all called voice over IP calls. But as you move, so voice over LTE is also an IP call, but the only thing in voice over IP versus voice over LTE is that voice over LTE gives you a guaranteed quality of service. So which means that the quality of the voice will be much better. You will have HD quality, which probably if you experience voice over LTE in the coming years when it's happening in India slowly, the quality of voice is extremely more powerful, and it's called HD voice. It's much more efficient, it consumes much lesser bandwidth, and it's very flexible in that sense. So this is another very, very important trend which is picking up. It has a dependence on the devices, and the device has a little bit of a limitation as of now in terms of the price points of the devices which and the availability of devices which are able to support voice over LTE, but this is getting bridged very, very fast in the coming months and years. Trend 4 we see is the use of small cells. Small cells mean heterogeneous networks. So where we are saying that, so this is the table here shows from 700 megahertz to 2300 megahertz different spectrum bands. And in all these different spectrum bands, the bar here shows how much you can reach. So as you go up in the spectrum, the reach or the coverage of that spectrum shrinks. Now when the coverage of that spectrum shrinks, then you need to have certain solutions in order to be able to penetrate into the walls of the buildings of the houses. And in order to do that, small cells is one solution. In fact, one of the most relevant solutions to give indoor and in-building coverage, where coverage holes can be filled with the use of small cells. And this is another very important trend which is picking up globally, where networks which need to get to the next level of capacities will have to build themselves, not by adding many, many more. Of course, there will be additions of macro sites wherever possible, but you will need to have a mix of macro plus micro and pico and smaller cells, which will enable you to be able to cover and give more capacities and coverage in the. And the fifth thing, like I said, the networks are becoming extremely complicated, extremely complex. So there are the macro cells, there are the small cells, there is Wi-Fi, there are IBS or indoor solutions. All this is getting kind of converged together, and the other thing we see is this evolution of an ultra-dense network, which we call HETNet or heterogeneous network in the future, where the requirement from the network will be very complex, but at the same time, the networks will have to build efficiencies around it in order to be able to give better service quality and experience to the end users. So I've just listed these 5 as the key trends, and I will talk in one slide about what is maybe a little ahead future, which is 5G. Some of you have probably heard about it and read about it. So 5G as a technology is the next step from where we are today, which is 4G is the evolution. And there are already studies and development going on in this area where 5G has the forums in 5G who are making all the development and who are doing the research have taken these three corners of a pyramid as their key missions to be able to develop 5G in the right way. So one of these edges you can see is massive broadband, which means that they want to develop 5G as a technology which can take a leapfrog from the today's capacities of 4G and be able to give gigabits of data rates in the future. So from the current, let's say 2G, 3G, 4G giving, like I showed, with even carrier aggregation 100, 200 Mbps of speeds, etc. You may need networks in the future which will be able to give gigabits of speed data rates, and that is one of the missions of 5G. The other mission is machine to machine, that we know this Internet of Things is getting exploded, machine to machine is becoming a reality, and if that happens, then you need to have a technology which will be able to enable and connect these devices, which will be billions of devices, which will create a lot of signaling traffic, which will create a lot of connectivity requirement, but at the same time, you cannot afford. For instance, if you do power meters, or if you do, I'll give you an example of power meters, for instance. So if you have a power meter, which is a connected power meter, it has a SIM card inside it. You cannot afford, and that SIM card just sends one SMS of a power meter rating or some kind of signaling message of the rating of that meter once a month. And it runs this whole device. The sensor runs on a small battery. Now, can you afford to have these kind of mass rolled out machine-to-machine IoT sensors, whereby every year or every 2 years or every 3 years you need to change the battery? It's not physically possible because they will be so spread out. So you have to evolve technology to an extent where you need to increase battery life in order to support this machine-to-machine and critical care going beyond the conventional ways that we see today of 10 years battery life. And the third critical element which is being worked in 5G is to create almost zero latency in the networks, which means that critical care, for instance, if you have connected cars and if you are driving, or not even connected, you said, hypothetically say now we are talking about driverless cars. So if you have a driverless car which is you are using, and it has a 10 millisecond or 15 millisecond latency delay in terms of it senses the GPS and then it says that this is a road and I need to take a right. In that 50 millisecond is good enough to have an accident. So you cannot afford to do that. So so you need to work on almost zero latencies for these critical applications. Even some medical applications will fall into that, and many more will come. So these are the three pillars in which 5G is working right now. It's work under process. The first rollout of 5G is expected by 2018 in the Olympics which are coming, and that would be the first demo, and we expect the commercial launch of 5G to be sometime in the 2022-2025 time frame. So that's the end of my presentation. The key message here is that we endeavor as Nokia to give GBS of personalized data per user per day in a profitable and secure manner. And for us, the future starts now. And I just end with this quote from Lincoln, which says, the best way to predict your future is to create it. And that's what we are trying to do here in Nokia. I hope you enjoyed this session, and now we will open up for some Q&A. Okay, I already see some questions coming. Is it possible to have zero latency, or is it achievable practically? Hamid. Yeah, so Hamid, I think I already presented and tried to explain this. I believe that technology has no possibilities. So technology means that the impossible, there is no word as impossible. Whether it has been done so far, at least I'm not aware, is, and we expect that almost zero latencies will be possible in the networks in the future. The other question I read is, how much data traffic do you see flowing on 4G in the next 5 years? By when do you see 5G becoming a reality in the Indian market? Okay, and the question is from Ankush Jain. Yeah, so I don't want to make very wild predictions here, and but our estimate is that 5G still will remain a very significant broadband technology for the India market as of now. And it will continue to do that for the next couple of years, and there are reasons for that. And I think the simple reasons is that the device ecosystem is much more mature in 3G. The penetration of 3G devices is far greater, and also the spectrum bands available in India, where a large amount of spectrum is available, is mainly in the 2100 band. So from that perspective, 3G will remain a very significant broadband technology. 4G has started coming. You have already experienced it. It is fantastic. 4G capacities slowly will, no, I wouldn't say take over or eat up. So 4G will be able to give you additional, or will take the additional capacities of data growth which is happening. And our estimate is that by 2017, approximately 20% of the capacities on the network at least will be handled on 4G networks. The other question is, would centralization into the cloud not also raise the risk of points of failure, which would become lesser but much bigger? You are absolutely right. I think the question is extremely relevant. And that's the reason when you build a cloud or when you build a server farm, you need to build multiple levels of redundancy into that system. So you have backup systems within that system, and it is also possible to create redundancies at a geographical level. So you could have an architecture, let's say if you are doing an HLR kind of, HLR is basically the register where the subscribers are stored, and you have that as a virtual system, but you could have 3 virtual systems, and then you could have a disaster recovery backup system also sitting in the network. So you can build multiple levels of redundancy and mitigate this risk of failure to a very, very large extent. What kind of application do you foresee that require 10 Gbps throughput? So I would say hard to predict right now. Things are developing. Video streaming may not require 10 Gbps at this stage, but there would be very extensive medical applications that I see where large amount of data needs to get transmitted from one location to the other location and require extremely fast networks in order to be able to deliver those critical reports and scans and stuff like that into. So that could be one example. There could be a zillion more industrial examples where again a large amount of scientific and data of designs, etc., which are extremely very heavy stuff, which needs to go from one product line location to the other product line location in a very instantaneous way and help. So many more examples can come. I think the possibilities are completely unlimited. How will the increase of 4G in India impact the need of tower fiberization? Do you see this as a challenge? Interesting question. 4G definitely would require a bigger pipe. I think there is no, because as soon as, I give you my own example. I have a 4G connection from the top two operators who are giving 4G, and I have two phones, so I have both right now. And in both these phones, my pattern of usage remains the same, but just because I'm able to access things much faster, my tendency to use has become more, and I am kind of hitting my limits of consumption of 4G almost every month now, or whatever quota I have on a monthly basis. So which means that when you have speed and when you have the network, you would require. So what it translates also is that when you have the higher technology, you will have a potential to consume much more, and that will all translate to having a bigger pipe which is coming to the end point in order to deliver all that data or carry it from one place to the other. Fiberization from that perspective is extremely, extremely important. I think there'll have to be a combination of microwave, fiber, and other kind of transmission technologies. But we agree absolutely that with 4G and these integrated sites, so as I said, the sites are becoming multi-radio sites where 2G, 3G, 4G are all on one site. So as a result of which, fiberization of those sites, maybe not to an individual site level, but at least to an aggregation point, is going to become very, very important, and I think that will be very critical. So it will be an important thing for the operators to consider, and I think it's already being looked at by all the operators in terms of increasing the fiber reach. There are programs by the government of India, and with the new government, I see more kind of traction happening on those fronts in terms of building fiber much faster. Will 2G last for long in the era of 4G and 5G, and how long? Okay, very interesting question, and we believe that you keep hearing these things about 2G completely dying down and being shut off in Europe and also parts of US. From India perspective, we are very strong believers that 2G will remain in India at least for the next 10 years, even more than that. And the reason is, number one, the affordability of the devices. Number two, the churn of the devices has to happen over a very significantly fast period of time. It will not happen. And the other thing is that the reach of 2G and the support of, for instance, I'll give you an example. In Europe, we keep hearing that 2G is going to be switched off. In Europe, they have these smart meters which are connected on 2G SIMs. And in these smart meters, you don't need very high redundancies. You don't need very high throughput. You don't need very high capacity, but you need this very, very small signaling which happens once or twice a month. So and it's penetrated into a very, very large area of these smart meters being spread out, and that's the reason Europe cannot take a decision to completely eradicate 2G. Same thing in US, we've been hearing many, many times that it will just be shut off. It is possible that it can be shut off in a market like US, but in Asia Pacific, or especially in India, I think there is still a lot. Voice will remain on 2G for some time to go. Then what is Nokia's strategy of building telecom cloud? Like I said, globally we are looking at two different strategies. One is looking at the core networks and building or trying to create a cloud environment, which is much easier to do. And the other, at the same time, what we are also doing is something which is called Cloud RAN. So most of our solutions which are coming now in the future are cloud-based solutions. In fact, a lot of our solutions, especially on the core side, the application side, etc., are even based on hardware which is completely off the shelf available in the market. So it could be an IBM, HP, or any other server hardware, and we would integrate with that hardware, give our software. So from an India perspective, yes, the challenge is that if you'd have to build a radio cloud now, you need the fiberization to happen. You need the fiber to reach those locations, which is still a little bit of a challenge, and it is, as I said, bridging fast. So our endeavor in India has been strategically to start building a cloud infrastructure starting from the core. So for instance, new core which is coming, like I said, voice over LT, IMS deployments, HLR, HSS deployment, if you understand those, are packet deployments, which packet core which is there, would be the first step of building some kind of a cloud network. Now, telecom service providers' role is more of network providers rather than service providers. How can we deal with the issue of privacy when the technology is growing exponentially? Shikha Sareen. Yeah, that's exactly the problem right now. You have nailed it absolutely correctly. The biggest challenge is the security and privacy. And I'm not getting into the big topic about privacy and which is going on in the TRAI discussion. But I would say if there is privacy, if there is security which can be built from an edge, the best place to do it is at the network operators level. Because if you go to the application side, it can be compromised and you have no control. You download a new application and you sign into blindly without reading, or even if you read, you cannot download that application because it won't allow you if you have not given your privacy rights to that particular company, and you expose yourself completely. So it is only the network operators, the trust to the network operators, which can help you bridge that security and privacy to some extent. Do you expect foresee X billion devices, things to communicate over the network, or perhaps a lot of them might talk over local channels like Bluetooth? Perhaps only few controller type of devices might end up communicating over the devices. So it's going to be a combination. Bluetooth is a technology, but Bluetooth as a technology has a limitation on the line of sight. What will you do when you have these Internet of Things devices, which are connected, which need to be connected? For instance, let's say connected cars. If you have connected cars, can you run a connected car on sensors which has only Bluetooth connectivity? The answer is no. Yes, you might be able to do some part of Bluetooth, like connecting your speakerphones or doing devices, connecting a fridge to a hotspot or a Bluetooth device which is in the house. But besides that, as soon as you want to increase the mobility and the range of the device, you need better connectivity. Where would be the applications of 5G networks when 4G network is enough to meet all requirements? Naveen Kumar. Yeah, see, again, we are restricting ourselves. We are talking about future networks, and we are talking about something that we are not even aware of. We are just seeing right now the exponential growth of data, and we are seeing what we see right now is, okay, video streaming is a brilliant application, and that, but it's changing extremely fast. These gaming applications, these high intensity bandwidth applications, which will come in the future. Even the amount of capacity which gets added onto the networks in the future from the new devices which comes. It seems to us that 4G is good enough, but it might not be the case 5 years from now, and that is why the development and the R&D on 5G has started now, or started a couple of years back, so that when we reach those bottlenecks and we need those 1,000 times more capacity on the data, and 4G as a technology is not able to deliver that, we are going to be able to complement it with 5G. I'll give you another which I did not cover here from a 5G perspective is 5G is also looking at these high range of spectrum. So beyond 3 gigahertz of spectrum, which is available in abundance to be able to use for mobile connectivity, which means that you have line of sight limitations there. So it's like more like a laser spectrum where every base station and every device will be connected on a like a pencil beam line of sight laser kind of communication. But those spectrums are available. You have like hundreds of megahertz of spectrum available in the 300 gigahertz and we up to, let's say, 9 or 10 or 12 gigahertz of band, and that's free spectrum. Nobody has so far used it or tried to use it. So 5G is trying to evolve itself that when you start exhausting the capacity of the spectrum, will you be able to give this massive broadband requirements in the future by using some of these techniques of using higher spectrum, etc. So that's how 5G is evolving. I'm sorry that too many questions I'm not able to take, and I'm just skipping some of them. As we know, in the long term, data revenue will also decline. How should operators drive their business case as most of the revenue will be with the OTT? That is, as I said in the presentation also, one of the biggest challenges that the mobile operators are facing right now. I wouldn't say how to beat the OTT, but a large portion of the revenue is getting eaten up. And I think the answer to that is the operators have and will start thinking about the OTT. I'm not saying they will become a pure play application provider, but they need to start thinking that the consumer is with them. The experience of the consumer is with them. Can they monetize that to some extent and take maybe not the full pie, but part of the pie, which is with the OTT player, and be able to monetize that into their revenues. So it's a very complicated topic. I cannot answer it in a couple of sentences, and we've done a lot of analysis on this in terms of how OTT should be. Its network is run by somebody else, and the revenue is going somewhere else, which is an important and very critical thing to see right now. But things like customer experience manager, analytics, keeping the control on the customer, giving him the user experience, these will be some of the answers in order to be able to take some pie out of that. As we know, in long-term, data revenue will also decline. How should operators drive the business case as most of the revenue will be with, I think it's the same question which I answered. Please share your views on M2M use cases in India. Which band will be more attractive for narrowband IoT? Interesting question. I think it's from Wang Bang. From an India point of view, I think narrowband LTE is an important topic that we have started now discussing. So 1800 is the LTE band in India. Potentially 700 is an upcoming LTE band, and 850 is another LTE band. I think it would be important. 900 still remains more or less a 3G band from India, or a 2G band, and that's how so far the evolution. Though 900 can support LTE, but it's in a very selective market. So from India perspective, 900 remains 3G. I would say that starting with narrowband LTE deployments in 1800 LTE band and then taking it forward to the 700 megahertz would be very critical and important from India from a future perspective. Do you see average revenue per megabit of operators in India to continue to fall, especially with the entrance of Reliance Jio? I don't want to make any comments on any specific operator. And I think this is a topic where it's a very important topic, but at the same time, Ankit Agarwal, it's very difficult to predict. I think my personal view is that the voice tariff have already reached its level of maturity in terms of wherever it needed to fall to. From a data perspective, it's difficult to predict what one operator will do versus the other, but I think that yes, there would be a fierce battle coming, and we'll see how that develops. But overall, from a consumer perspective, I think it will be a good thing. You will have better networks. You probably will have cheaper data available. So it's all about a game about, the whole thing is about volumes and scale. So if the data traffic contributes, which is contributing, let's say 12 to 15 or 17 to 20% right now of the revenues, is able to increase the revenue of the operators, there is no reason why they will not be able to price it better for the end consumer and give it as long as more data is getting consumed and they're getting some pie out of that revenue. It doesn't work where you reduce the traffic tariff and you start making less money. So it's a very critical balance that they will have to create, and let's see how that proceeds. I think it's too premature to answer something like that. How Nokia found the big data technology of any use of driving insight into the networks? If so, in which areas? Anoop. Yeah, Anoop, I think good question. I think we've already overshot the time, if I can see, but that's okay. I'll give you some of the examples of how we have used big data analytics. One of the examples is something which we call predictive operations. In predictive operations, what we do is we analyze the faults in the network over, let's say, a 6-month to 1-year period. And then we analyze that data and say that when a base station, for instance, went down, then 3 days or 5 days before that base station went down, were there any KPIs in the network which got impacted? Which means, so it's like an ECG of the network. I'll give you a very simple example. When the doctor sees your heart ECG, he looks at a variation in the heart rate and is able to predict that at some point of time, are you susceptible to get a heart attack or you get susceptible to get some kind of a heart disease. Similarly, we do a predictive analysis of big data for maybe 6 months or 1 year of the previous history, and then we say that what was the ECG of this particular base station when the site went down, and were there certain things that happened before, and if they happened before, then we start fingerprinting them to the actual live network, and then we say that okay, if this happened, this base station got down, now this is happening again, there is a potential that the base station can go down again, so rectify this problem now. And by that itself, you are able to reduce the outages by a very, very significant number. I don't remember the number, but I think we had done an analysis where about 20 to 30% site outages can go down. And that way, not only your network becomes more enabled and it's a better quality network, but also it helps to increase the revenue, because site going down means a loss of revenue for the operator. So this is one example. The other example could also be for instance, this customer experience and this thing, customer experience management. For instance, you analyze the big data or the data that is available, see the usage pattern of certain age group of people, then send them marketing campaigns around certain things that they want to do, and try to monetize that. So you are sitting in a shopping mall and you know that there is a group of people who are for instance, always seen in, or they have a trend of using or visiting or using certain applications in that shopping mall which are linked to, so let's say you're buying pizzas or something like that, and you send them some promotions so that you attract them to, and then do a revenue share with those retailers, and then be able to monetize some part of that. So these are a few examples, and there could be many, many more. Yeah, I think more or less I might have missed a few questions, but I tried to cover whatever I could. And should we end now, or do we still continue?
We can take.
Okay, we can take one last question. It was the last. As Nokia found 4G and 5G rollout, what future impact will you see of small ISPs who offer internet through local cable networks and new Cat 6 or B2B using point-to-point Wi-Fi. Vishal Singhvi. So, our view is very simple. The explosion is happening the appetite for data exists. We are a country who is suffering from very, very poor home broadband penetration. Mobile has come as a rescue to us in being able to give basic internet connectivity and offer some kind of data experience. I believe that whether it's an ISP, whether it is a mobile operator, whether it's a 2G operator, whether somebody is a Wi-Fi operator and able to give, there is potential for everybody in the market. The appetite is so large that everybody will have a role to play in order to give the experience to the end user. And these will all be complementing technology. So we are not saying Wi-Fi is bad in any way. Wi-Fi will remain a complementing technology because the way the data is growing, we will need all these technologies possible in order to be able to give a good experience and fulfill the need of the end consumer. Okay. I think mostly I have taken over increase fortune. Yeah, I think more or less I've taken most of the questions, it looks like. Yeah, I think then we can end this session and thank you all for joining in.